Hi, welcome to a little demonstration about comparing floating point numbers. This is program 311 out of your book called Good Bad Float Compares. And here is the program. We start out with I'll make that a little bigger. We start out with a variable called sum, and it's 0.0. 0.0 is a double because it's a literal, and then we cast it into a float. Okay, a float, as you recall, has usually about 7 decimal places. Then we have a variable called nickel, which should be worth 0.05. Okay, look at that. Can you see that the double value for nickel is 0.05, a whole bunch of zeros, and 278? Nice. Okay, so let's debug our way through this. And we'll get to see exactly what's going on. First, these all have garbage values because we haven't assigned anything yet. So let's take one step, and sum is now 0, absolutely 0. It's a float. The double is actually also 0. Next step, nickel. Nickel is, oh, look at that, 0.05, many zeros, and then a 7 at the end. This double, it's not, there we go. And the reason that is this double, look at that, is 0.05, lots of zeros, and a 3 on the end. Okay, one more step. Dollar looks like 1.00, what we expected to. And the double, okay, then the double version of 1.0 is also all zeros. So you can see it's kind of random whether you end up with what you expect with 1.00. Would that be 1 with 15 zeros for a double, or 7 zeros as a float, or is it going to have random numbers in it? You just don't know. So here's a little exercise. I'm going to put another breakpoint down here. I am debugging, and debugging is such a great way to follow values in your program. So here I am at this for loop, and rather than go through each time, I'm going to go down to the next breakpoint. Here is sum. It is 1 point, some zeros, and then 12. Okay, so now we check if sum equals dollar. Well, sure as heck is not. So we keep going, and then we say sum is not dollar. Now, a better way to check is to check if the difference between the two of them is less than a very small amount. So if the absolute value of sum minus dollar is less than 0.0001, and what does that do? Well, remember the problem in sum is, let's see, there's 1, 2, 3, 4, 5, 6 zeros and then 12. Here we have 4 zeros and the change is in the 5th zero. So if the difference between these two numbers that we're hoping are equal is less than 0.0001, then we can be confident that it is true. And it says, yes, that's true, sum is 1.00, sum is a dollar. So the difference is that you cannot use this notation of the double equal sign unless you have an integer. If you have a floating point number, you must check the difference between the two numbers that you are comparing and check to make sure that the difference between the two of them is less than a very small number. And you don't even know which one might have extra numbers trailing numbers, and so you need to use the absolute value. Okay, makes sense? So when you have floating point numbers, you can't use equals equals. Just remember that and you'll be good to go. See ya. Bye.